Hello, this is the Lab on Lego project. It involves me, Isaac, a chemical engineer, Stephen, a mechanical engineer, and our supervisor, Peter Kovalsky. This project is inspired by the MIT experiment where they used interchangeable blocks, Lego bricks, as a medium for a microfluidic system. This allowed the bricks to be interchanged and which allowed the system to be changed. They did this by milling microchannels into the bricks, which were then encapsulated to enclose the channels. We'll be using this idea to design and develop a system that will allow us to separate the internal flow within capacitive deionization cell. Capacitive deionization, or CDI, is a relatively new technology that passes a fluid through a micro gap between two porous electrodes like activated carbon. When an electrical current is applied to the electrodes, it creates an electrical difference between the electrodes, which causes charged ions in the fluid to be attracted to the electrodes. Because of this, it is an attractive technology for the desalinization of water, as it could be low cost along with a low energy requirement. There is an issue that can occur with a CDI cell, which is fouling. It is hypothesized that pH is a factor in this process, and from simulation it is believed that a stratification of pH occurs. Our project aims to prove this theory by developing a microfluidic device that can separate the flow, allowing for a pH measurement to be taken.
In the semester, we accomplished 3 different tasks. The first part is CNC milling. We have studied 3 different milling methods and the using of various tools to machine the surface of Lego. The second part is to using the laser to processing the sealing film on the surface of Lego by comparing different G-code to fit various sizes of Lego. The third part is using of 3D printer technology to print different functional Lego brackets. By studying different printing direction to ensure a better fit with the original Lego bracket. For the future work, CNC laser cutting. The problem of burning of the sealing film during the laser cutting need to be solved, and the film on the both sides of the protective film need to be removed to have the best cutting effect, but the sticker side of the protective film will be contaminated. Modeling and simulating. Once we know how to design and develop a microfluidic system using Lego brackets, we can design a system in console that we can create that will be produce the pH stratification, separate the following and measure this pH in the real time. Lab on Lego. It is necessary to assemble the Lab on Lego device in a short time and make sure the cell is intact to meet the requirement of the next experiment. For the final experiment, the capacity dionyzer was designed to meet the specifications and assembled with Lab on Lego for the final experiment. Design knapsack. If we have completed our goal, we can design system to improve the using of knapsack in the New Zealand allowing for the different dosage and pesticide size that can be used. Thank you for listening.